Saudi Arabia is often described as a major military power because of its enormous defense spending and access to some of the most advanced weapons systems produced by the United States and Europe. But what exactly does Saudi Arabia have? What missiles protect its cities? What weapons are carried by its fighter aircraft? How does Saudi Arabia defend itself against ballistic missiles, cruise missiles, aircraft, and drones? And perhaps most importantly, how is the kingdom building its own defense technology instead of depending entirely on foreign suppliers? In this documentary, we will examine Saudi Arabia's publicly known missile arsenal, its layered air defense network, combat aircraft weapons, naval missile capabilities, radar and electronic warfare technology, drones, and the growing Saudi defense industry. One important point before we begin: exact inventories, deployment locations, readiness levels, and some weapon configurations are not publicly disclosed. So this documentary focuses on systems that have been publicly reported or officially documented. Saudi Arabia does not rely on a single missile family. Instead, its military uses a mixture of ballistic missiles, surface-to-air missiles, air-to-air missiles, air-to-surface weapons, anti-ship missiles, and precision-guided bombs. This creates a layered military structure. At the strategic level, Saudi Arabia has historically operated Chinese-origin ballistic missile systems, most famously the DF-3A. The DF-3A, also known by its NATO designation CSS-2, is a long-range ballistic missile system associated with Saudi Arabia since the late 20th century. Saudi Arabia has also been publicly associated with the Chinese DF-21 family. These systems are very different from the defensive interceptors used by Patriot or THAAD. A ballistic missile is designed to deliver a payload over long distances. An interceptor missile has a completely different mission: find the incoming target, track it, calculate an interception solution, and destroy or defeat the target before it reaches the protected area. That difference is at the heart of Saudi Arabia's modern missile strategy. When people discuss Saudi Arabia's air defense, one system immediately stands out: Patriot. The American Patriot system forms a major part of Saudi Arabia's integrated air and missile defense architecture. Patriot can engage different types of aerial threats, including aircraft and certain missile threats, depending on the interceptor and configuration. One of the most important interceptors is the PAC-3 family, and Saudi Arabia is now moving toward an even more advanced capability. In January 2026, the United States approved a possible sale of 730 Patriot PAC-3 Missile Segment Enhancement, or PAC-3 MSE, interceptors to Saudi Arabia. The proposed package was valued at approximately $9 billion. That number alone demonstrates how important Patriot remains to the kingdom. The PAC-3 MSE is designed specifically for advanced air and missile defense missions. Unlike a traditional explosive warhead approach, PAC-3 interceptors are associated with hit-to-kill technology. In simple terms, the interceptor attempts to destroy the incoming target through direct impact. This makes the Patriot system one of the most important layers between an incoming missile and the infrastructure Saudi Arabia is trying to protect. But Patriot is not the highest layer of Saudi Arabia's missile defense. That role increasingly belongs to THAAD. THAAD stands for Terminal High Altitude Area Defense. The system is designed to intercept ballistic missile threats during the terminal phase of their flight. The U.S. Missile Defense Agency states that Saudi Arabia has signed multiple foreign military sales cases for 7 THAAD batteries and associated equipment. That makes THAAD a major part of the kingdom's long-term missile defense architecture. Think of the system as a higher defensive layer. A simplified concept looks like this. Long-range detection identifies a threat. Command and control systems process the information. THAAD attempts to engage appropriate ballistic missile targets at high altitude. Patriot provides another defensive layer closer to the defended area. Shorter-range systems can provide additional protection against aircraft, drones, and other low-altitude threats. This layered concept is extremely important. because no missile defense system can guarantee that every incoming missile will be intercepted. The objective is to create multiple opportunities to detect, track, intercept, and defeat the threat. Saudi Arabia's air defense network is much larger than Patriot and THAAD. The kingdom has operated a variety of shorter-range systems, including systems associated with French and American defense technology. Publicly reported examples include Crotale, Shaheen, Mica-based systems, Stinger, Avenger, Mistral, and other point defense capabilities. These systems have different purposes. A long-range missile defense system is not necessarily the best tool against a small drone flying close to a military base. Similarly, a short-range system cannot replace a high-altitude ballistic missile interceptor. This is why Saudi Arabia uses multiple layers. At the short-range level, the objective is to defend critical sites against low-flying aircraft, helicopters, cruise missiles, and increasingly drones. This part of the network has become particularly important because inexpensive unmanned systems can create a difficult defense problem. The defender may need an expensive interceptor to defeat a relatively cheap drone. That is why Saudi Arabia is also exploring technologies such as directed energy weapons and advanced counter-drone systems. One of the most interesting developments in Saudi Arabia's air defense environment is the use of directed energy technology. Public reporting has identified Saudi operation of China's Silent Hunter laser system. The concept is very different from a conventional missile. Instead of launching an interceptor, a high-energy laser directs energy toward a target. The potential advantages are obvious. There is no traditional missile flight path. The weapon can potentially engage certain small aerial targets rapidly. And as long as sufficient power and line-of-sight conditions are available, the system can potentially continue engaging targets without carrying a conventional missile magazine. But lasers also have limitations. Weather can matter. Line of sight matters. Atmospheric conditions can affect performance. And the system requires substantial electrical and cooling infrastructure. So, directed energy is not replacing Patriot or THAAD. It is another layer. Now we move from ground-based defenses to Saudi Arabia's offensive air power. The Royal Saudi Air Force operates one of the most powerful F-15 fleets outside the United States. Its F-15 family includes advanced variants such as the F-15SA. These aircraft can carry a wide range of air-to-air and air-to-ground weapons. Among the publicly associated air-to-air missile families are the AIM-9 Sidewinder and AIM-120 AMRAAM. The AIM-9 is primarily a short-range, infrared-guided air-to-air missile. The AIM-120 is a radar-guided medium-range air-to-air missile. Together, these weapons give Saudi fighter aircraft different engagement options. A pilot does not need to use the same type of missile against every target. The aircraft's radar, sensors, data links, electronic systems, and weapons all work together to provide a broader combat capability. Saudi Arabia's F-15 force has also been associated with precision-guided air-to-ground weapons. These include satellite-guided JDAM weapons and laser-guided paveway families. The important development here is precision. Modern air warfare is no longer simply about dropping large numbers of unguided bombs. The objective is to deliver the right weapon to the right target with much greater accuracy. Saudi Arabia also operates Eurofighter Typhoon aircraft. The Typhoon gives the Royal Saudi Air Force another advanced fighter platform. The aircraft can employ European weapons and has been integrated with modern air-to-air and air-to-ground systems. One important missile family associated with the Typhoon is the MBDA Meteor. Meteor is a modern beyond visual range air-to-air missile designed for engagements against airborne targets. Its ramjet propulsion gives it a different performance profile from many conventional air-to-air missiles. Saudi Arabia's European aircraft fleet therefore complements its American F-15 force. This is an important characteristic of Saudi military technology. The kingdom does not depend on a single supplier. Instead, it combines American, European, and increasingly Chinese-origin technologies. That creates capability. But it also creates a major integration challenge. Different systems must communicate. Different radars must exchange information. Different command systems must understand the same battle space. And different weapons must be maintained, supplied, and upgraded. Saudi Arabia also possesses a wide range of air-to-ground weapons. Publicly documented American systems associated with Saudi aircraft include precision-guided bomb families and air-launched weapons. One important example is the AGM-84 Harpoon family, associated with anti-ship missions. Air-launched cruise-type weapons are fundamentally different from ballistic missiles. A ballistic missile generally follows a high-energy trajectory. A cruise missile can fly much closer to the Earth's surface and use aerodynamic flight. This can make detection and interception more complicated. Modern cruise missiles can also use sophisticated navigation and guidance technologies. For Saudi Arabia, air-launched weapons provide its fighter aircraft with the ability to conduct missions beyond simple air-to-air combat. Saudi Arabia's maritime forces also require anti-ship weapons. The kingdom operates a modern fleet of surface combatants and other naval platforms. Anti-ship missiles are designed to threaten ships from significant distances. One publicly associated weapon is the Harpoon family. Saudi Arabia has also operated European naval systems and platforms equipped with modern missile technology. The basic concept is straightforward. A naval missile system uses sensors and targeting information to identify an enemy vessel. The missile is launched. It travels toward the target using its guidance system. Near the target, the missile seeker attempts to acquire the ship. The weapon then attacks the vessel. Modern naval warfare is therefore heavily dependent on sensors, communications, electronic warfare, and targeting information. The missile itself is only one part of the system. A missile defense network is useless if it cannot see the incoming threat. That is why radar technology is just as important as missiles. Saudi Arabia operates a large network of surveillance and fire control radars associated with its American and European systems. Patriot batteries use powerful radar and engagement systems. THAAD has its own advanced and TPY-2 radar architecture. Other surveillance systems provide broader airspace awareness. The goal is to create a continuous picture of the battle space. Imagine a missile being launched hundreds of kilometers away. The defense network needs to detect it, then track its movement, then determine what type of threat it represents, then estimate where it is going, then determine which defensive system should respond, then launch an interceptor, and finally assess whether the target was successfully defeated. This is not simply a missile problem. It is a sensor, communications, computing, command and control, and interceptor problem. One of the least visible parts of Saudi Arabia's military technology is command and control. Modern air defense depends on computers and communications networks connecting sensors and weapons. A radar may detect an aircraft. Another sensor may detect a missile. A command center must combine the information. Operators then determine the appropriate response. The more integrated the network becomes, the more useful every individual sensor can become. This is why modern militaries increasingly talk about integrated air and missile defense, or IAMD. The goal is not to have isolated batteries. The goal is to connect them. Saudi Arabia's latest American defense agreements explicitly describe improved Patriot capabilities as part of an upgraded integrated air and missile defense system. Another major part of Saudi military technology is electronic warfare. Electronic warfare involves the electromagnetic spectrum, radar, radio communications, navigation signals, data links, sensors. All of these depend on electromagnetic energy. A modern military therefore needs to protect its own signals while attempting to disrupt or deceive an opponent's systems. Saudi Arabia's defense industrial strategy specifically includes defense electronics, radars, sensors, communications, and electronic warfare. This is also an area where Saudi Arabia is attempting to build more domestic expertise. The modern battlefield has changed dramatically because of drones. Small, unmanned aircraft can perform surveillance. Larger systems can carry weapons. Other drones can provide communications or intelligence. Saudi Arabia has invested heavily in unmanned systems and has also pursued international partnerships. In 2024, Saudi Arabian Military Industries announced agreements involving Baykar for manufacturing capabilities and development of unmanned systems inside the kingdom, including technology transfer and intellectual property-related cooperation. This represents a major strategic shift. Saudi Arabia is no longer interested only in buying complete weapons. It increasingly wants to manufacture, maintain, upgrade, and eventually develop more defense technology domestically. This brings us to one of the most important parts of the story. Saudi Arabia is trying to become a defense producer. The central organization is Saudi Arabian Military Industries, or SAMI. SAMI was established in 2017 under Saudi Arabia's broader Vision 2030 strategy. Its areas include air systems, land systems, weapons and missiles, ammunition, and defense electronics. The Public Investment Fund describes SAMI as a major vehicle for developing Saudi military industrial capabilities. Saudi Arabia's General Authority for Military Industries has also set a goal of localizing more than 50% of military expenditure on equipment and services by 2030. This means the kingdom's long-term strategy is changing. Instead of buy, operate, replace, the ambition is increasingly buy, learn, produce, maintain, upgrade, and eventually develop. When people see a list of Saudi missiles, it is easy to assume that the missile itself determines military power. But that is not how modern warfare works. A missile requires intelligence. It requires targeting. It requires communications. It requires trained personnel. It requires logistics. It requires maintenance. It requires sensors. And it requires command authority. The same is true for air defense. A Patriot launcher sitting alone on a military base is not an integrated missile defense network. The real capability comes from connecting the launcher to radar, command systems, communications, intelligence, and other defensive layers. This is why Saudi Arabia is investing in electronics and defense technology as heavily as it is investing in missiles. So, how can we visualize Saudi Arabia's modern air defense structure? At the highest level, strategic missile systems provide long-range strike capability. Then fighter aircraft provide air superiority and long-range aerial combat capabilities. Then high-altitude missile defense, such as THAAD, provides a ballistic missile defense layer. Below that, Patriot provides another major air and missile defense layer. Then medium and short-range systems defend individual installations. Then point defense weapons and counter-drone systems address smaller threats. And behind all of this are radars, satellites, communications networks, command centers, electronic warfare, and logistics. It is a layered architecture. Not a single weapon. Not a single missile. Not a single aircraft. A network. Saudi Arabia's geography and strategic position explain much of this investment. The kingdom is located in one of the world's most heavily militarized regions. It is surrounded by states and non-state actors with access to ballistic missiles, cruise missiles, drones, aircraft, and other long-range weapons. Saudi Arabia also contains critical infrastructure: oil facilities, air bases, ports, power plants,